Hello my dear friends, students and viewers. This is Sir Palmath and welcome to my video channel. In this video, we are talking about the introduction to permutations and permutation of n objects using the factorial notation. So let us begin with our learning objectives for our today's topic. So hereby our learning objectives for today. So we'll be going to illustrate the permutation of an object. Next, you will be going to derive the formula for finding the number of permutations given the n objects. And thirdly, you will be going to solve problems which involves the permutation of n objects using the factorial notation. So these are the following learning objectives of today's lesson. So my dear viewers, are you ready to study some of these examples? And you'll be going to learn about the permutation of n objects. So let us start. So today we will be going to discuss about the introduction to permutations. So you will be going to define what is permutation. So when we say permutation, a permutation is an arrangement of objects or events which the order is important or significant. So it is also an arrangement of objects in a definite order or the ordered arrangements of any distinguishable objects without allowing repetition among these objects. So speaking of the word permutation, this is an arrangement of set of the objects or events which the order is important. So there is a significance about their arrangement of objects. So we having the definite order of ordered arrangements of different objects without allowing repetitions. So today we'll be going to discuss about the permutation of n objects. So in this type of permutation, it is known as the factorial permutation, and this permutation process, you will be determine the number of possible ways using the factorial notation. So the number of possible permutations in a given set of objects, it is defined by n factorial, and that is having our formula on the given formula. N factorial is equal to n times the quantity of n minus 1 times the quantity of n minus 2 times the quantity of n minus 3 times until reaches to 3 times 2 times 1, where the value of n is any positive integer or what we called as any counting number or natural numbers. Okay, so let's go back to the previous lesson what we have on the previous video. So which we are talking about the factorial notation. So again, the factorial function of any positive integer n is defined by the product which is expressed in a given formula. So we have n factorial is equal to n times the quantity of n minus 1 times the quantity of n minus 2 multiplied by until reaches to 3 times 2 times 1. So again, my dear students, viewers, so where the value of n is any natural number or known as counting number. Here are some of their factorial values which from 0 to 10, which I have already discussed on the previous video. So let us begin with 0 factorial. So 0 factorial is equal to 1. It is known as their special case because it is factorial 0 which is equivalent to its the empty product. So empty product which has already expressed with no factors, and it is resulting to multiplicative identity which is equal to 1. So we have 1 factorial is equal to 1, 2 factorial is equal to 2, 3 factorial is equal to 6, 4 factorial is equal to 24, 5 factorial is equal to 120, 6 factorial is equal to 720, 7 factorial is equal to 5040, 8 factorial is equal to 40,320, 9 factorial is equal to 362,880, and 10 factorial is equal to 3,628,800. And we all know that the value of n factorial is equal to their own formula. So we have already derived on the previous video. So my dear friends, students, and viewers, so let's move on to our illustrative examples on how will you going to solve these word problems which involves the permutation of n objects. So let us begin with our first illustrative example. So which are titled scrambled letters. How many possible arrangements of letters in a given word form? So to solve this problem, here is the given solution. So there are only 4 letters in the word form. So it was spelled as F-O-A-M. So by the concept of fundamental counting principle, we have already discussed on the previous video. So we have the following different methods. So let us begin with letter A, which is the listing method. So we have already encountered by listing all of these possible outcomes. So these are the following. So we have 1, 2, 3, 4. So there are only 4 outcomes in every column. So 1, 2, 3, 4, 5, 6. So we have 6 columns multiplied by 4, so which is 24 possible arrangements of the letters in the word form. So these are the following outcomes using the listing method. So my dear viewers, friends, and students, we have another solution or another way of determining the number of possible outcomes using the fundamental counting principle, so which are using tabular method. So we all know that there are 4 choices to be put on the first letter among of these letters F-O-A-M. After you choose the first letter, you cannot be used this letter all over again. And we have to subtracting the remaining 3 choices to be put on the next letter. Second, third one, we will be going to put 2 remaining choices on the third letter and 1 remaining choice on the last letter. So by the fundamental counting principle, we have the following. So the first letter, which is 4, the second letter is 3, the third letter is 2, and the fourth letter, which is equal to 1. So that is 4 times 3 times 2 times 1. So we have the product, which is 24 possible arrangements. So 4 times 3 is 12 times 2 is 24 times 1, which is 24 possible arrangements. So we have already the same answer to the previous method. So in factor form, 4 times 3 times 2 times 1 is the same as 4 factorial. And we have already discussed on the formula using the factorial notation, which is 24 possible arrangements. So my dear viewers, friends, and students, there is an alternative solution to solve this problem. So in avoid to consume time and effort, so we have our alternative solution. So we let n be the number of objects given in a permutation problem. So let's go back to the given problem, that how many possible ways when you arrange these letters from the word form. There are only 4 letters. So we have F-O-A-M, so we let n is equal to 4. So by the use of factorial permutation or the permutation of n objects, we have the following. So we all know that the formula of permutation of n objects, which is n factorial. So n factorial is equal to 4 factorial, so we have already substituted the value of n. Then, so the equivalent for 4 factorial, which is expressed in expanded form, so we have 4 times 3 times 2 times 1, and we have already known that the factor or the product of these 4 numbers is 24 possible arrangements. And that is our answer to the given problem. So among these 3 solutions, we have which already explained in this problem, so we can arrive at the same answer. So let's move on to our next illustrative example. So my dear students, friends, and viewers, let's take a groupie. So in this picture, we have only 8 persons on the picture taking in a row. So the question is, so how many possible arrangements of a group of 8 people in a picture you're taking in a row? So to solve this problem, here is the solution. So these are only 8 people captured in a picture taking in a row. So we let n be the number of objects given. So in this picture, there are only 1, 2, 3, 4, 5, 6, 7, 8. So there are only 8 people. We let n is equal to 8. Thus, the number of possible arrangements of 8 people in a row in the picture taking is, so we use the formula for n factorial, 8 factorial. So the expanded form for a factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or we cannot omit the last factor, which is 1, until reaches to 2. So we get the product of first 8 numbers, which is 40,320 ways. And that is our final answer. So let's move on to our last illustrative example for permutation of n objects. So which title is Grand Prix. The racing club organizes races in which 5 cars. We have the Alpha, Beta, Charlie, Delta, and Epsilon are participated. In case without a tie, how many different race possibles are possible? So to solve this problem, here is our solution. So we all know that there are only 5 cars in a race. So we let n would be the number of objects. So we let n is equal to 5. Simple as that. So there are only 5 cars named Alpha, Beta, Charlie, Delta, and Epsilon. So thus, the number of possible race results are, we have used the formula for factorial notation. So n factorial is equal to 5 factorial, which is equivalent to 5 times 4 times 3 times 2 times 1. So which has a possible ways, which is 120. And that is our final answer to the given problem. So my dear friends, students, and viewers, so I hope you will understand some of their concepts about permutation of n objects and its illustrative examples. That's the end of our video. So thank you very much for watching. So please like, share, subscribe, and hit the notification bell to update for our new videos. So here at Sir Palmath TV. So my dear students, friends, and viewers, so thank you very much. See you on next video, and God bless us all.